Okay, thank you so much for having me. This conference really means a lot to me. It was the conference where I had my first talk, my first workshop ever. So this is something very special to me. So today we're going to talk about Cypress. And before I dive into my talk, I really want to give a big shout out to Gleb. He's taken the time to answer some of my questions. He's helped me to prepare for my talk, to improve some visuals. So Gleb, you're really awesome. So thank you so much, and also for all the work he and the team does on Cypress. So let's start with a few questions. So how do you test your front end? That's a good answer. So there's a couple of things we can do, right? This is the testing environment, and I think we all know that. For example, we can write unit tests. We can write some functions. We can write unit tests to test our functions, our business logic, and even UI components in isolation. But the problem is with unit tests, and they're totally valid, and we should write mostly unit tests, I would say, or a lot of them. But the problem is when we try to put several pieces together, right? That's when the problems arise. So, for instance, it becomes very difficult because of a lot of things can go wrong. For instance, our UI, so whether it's our UI, whether it's our web API, or even the deployment. So when we put things together, a lot of things can go wrong, right? And we can have all the unit tests in the world, and they won't help us in those cases, right? Because it's really not integrating multiple units. It's just units in isolation. So, and that's where integration and end-to-end tests come actually into play. That's when we test things from one end to the other and all the way back. So with end-to-end tests, we would test our application in a deployed version, whereas with integration tests, we would basically, well, most likely stop API requests and stuff like that to speed up our tests a little bit. So end-to-end tests are very useful. That's no doubt. But the question is, do you write end-to-end tests or integration tests? If so, are they slow? Like, does it take a little bit of time to spin them up to write those tests? Selenium is slow, all right. How about this? Have you ever experienced flaky or unreliable tests? If you don't know what that means, so basically this means the tests work on my machine, but it doesn't work on other machines. It works locally, but not on CI. And, tests just randomly fail. This is some pretty common flaky symptoms. So flaky tests are really the most frustrating thing in the world of testing. Believe me that. There's nothing more frustrating than flaky tests. How about this? Do you ever, do you and your team have a hard time maintaining tests? Your web UI tests. So it's like playing Jenga. I love that game. Where each of these blocks is like, is a building block, is a part of our UI. And making the smallest change to our UI can cause automated tests to fail, right? It wouldn't be a big deal if it was easy to find out why our tests fail, but that's, with most tools out there, that's not always the case, right? So also, it's not often the size, but it's how we write our tests that make it, well, unreliable and really hard to maintain. How about this? Do you think it's enjoyable? Is it hard to write tests with the tools you use right now? Is it fun? Is it enjoyable? Is it easy? Depends. Yes, it depends. Honestly, I don't think so. Because in general, it's not about, so take Protractor for instance. Protractor has a lot of global, like top-level objects, right? There's browser, there is element, there's by. And it's a lot of cognitive load. It's not that easy to always find out which global objects to use in our tests, right? So it's definitely having less global objects makes it easier and faster to write tests. So all these things, they cause friction, and friction pushes us developers to a point where we then sometimes respond with something like, well, I don't have time for this, or, well, nor the budget. So, and this results that we basically ignore testing completely, right? But, so this basically we end up with just unit tests, or I've seen a lot of applications where developer only write unit tests and they kind of ignore integration tests and end-to-end tests. So this is what we end up with. Because they're easy and the tooling we have is pretty tight. So it's pretty nice. And if we're lucky, we end up with something like this. We also have linters, and if we use TypeScript or linters, we get some static tests as well, some static code analysis that help us, well, write applications that are less error-prone. But what does that mean now? Well, it means that we have a serious problem. We have a serious one. But I'd say welcome to the club. And you're definitely not alone in this club. There's so many developers that constantly echo the same frustrations. And let's be honest, most of us don't write many integration and end-to-end tests. I think that's a fact. That's what I figured from looking at code and working with a lot of clients. So that's pretty sad, right? Because end-to-end tests and integration tests are very useful. We know that, that's no doubt. And they definitely should be a first-class citizen of our application. So from a business perspective, they're extremely easy. I don't want my users to be the first to test my application from a consumer perspective. That can be very, very costly, and it will eventually backfire on us big time, right? It's going to be very expensive. So the question is, what can we do? Like, we have all these problems, all these frustrations. What can we do? And that's what this talk is about. I want to introduce you to a testing tool for the modern web, and that is called Cypress, because the web just has evolved. So this talk is going to be about Cypress, and throughout the talk, we're going to see why Cypress is so outstanding and what makes it so different and reliable compared to some other tooling, some other testing tools like Selenium. And to make this a little bit more fun, I'm going to live code. And we're going to write some basic tests. We're going to explore HTTP. We're going to work with local storage even. And at the end, I hope that I still have time to show you how to integrate Cypress with continuous integration. But I cannot promise that. A little bit about myself. I'm Dominik Elm. I'm a trainer at ThoughtRamp, so I basically give trainings all over the world. I love Angular. I love reactive programming. Sometimes I write some blog posts. You can also find me on Twitter. Duh. And as Quentin already mentioned in the beginning earlier today, Quentin and I have been working on this application called Angular Checklist. It's open source. Check it out. It would be awesome to have you as contributors. So probably the biggest question in the room is, what is Cypress? So Cypress is an end-to-end testing framework that claims to make testing fast, easy, and reliable for everything, for anything that runs inside the browser. It is free, it is open source, and it's MIT licensed. So, setting Cypress up is easy peasy. All we have to do is just add Cypress as a dependency, so it's just a single install command. So this is what we have to do. Just add it as a def dependency, and that's it. This means that Cypress basically is an all-in-one solution. Compared to different tools, compared to Selenium, there's a lot of things we have to install, right? But with Cypress, it's an all-in-one solution, and we get several great testing tools in one. For instance, it uses Mocha for its BDD syntax. It uses Chai for writing assertions. It uses Cynon for spying and mocking and stubbing objects, and several other utility libraries like Lodash and jQuery, which are exposed on the global Sci object. So I'm using NPM here, which is recommended by the Cypress team, but you can also use Yarn if you want. Okay, so once Cypress is installed, there's two ways to execute Cypress. Once it's executing it locally, this would be just calling open on Cypress. Cypress is a binary that is, once you install it, it's going to be downloaded and it sits on your machine. And on CI, we would run a different command, which is run, and then with a flag --record, which will record all my tests on the dashboard. There's also a dashboard. So this is, well, we can use npx to make this a little bit nicer, so we don't have to look in the npm bin directory. So we can also use just npx. All right, so you want to try this out? So let's see what this does. And for that, I quickly have to turn off the display. Sorry. How do I? Oh, arrangement probably, yeah. Show. That's it. So what I've built is we're going to use an application. It's a to-do MVC application, but I've implemented some more features to make it a little bit more fun and to also showcase the power of Cypress. So this is a to-do MVC application, so it's protected by a login page. So if I log in, and you can guess the password, I'm going to click on login. Oh wow, the contrast is really bad. But it's a to-do application. I can say go to NGBE. I need to eat. So there's also some animations, which is sometimes problematic for end-to-end tests and integration tests. So this is the application. This is what we want to test. So I'm going to head over to my terminal. I've already installed Cypress, so I don't want to lose some time here on stage. So what I can do now, and I'm going to make this a little bit bigger, is I'm going to run Cypress. So npx Cypress open, right? This is going to open an Electron app that is provided by Cypress. It's going to take a while, so there it is. This is Cypress. I cannot zoom in, sorry for that. But what we can see here is there's 3 tabs. The first one says tests, second one run, and then some settings. So here, Cypress lists all the spec files that I have in my application. And I can select the browser here in the top right corner. Currently it's only Electron and Chrome and Chromium-based browsers, but they're working on browser support. So I can select Chrome. I can hit on Run All Tests. And then the actual UI from Cypress opens. So this is what Cypress looks like. We can see that our application is running on the right, and on the left we have that pane, right? So can I zoom in? Yes, I can zoom in. So here we see all the tests that I have in my application, all the integration and end-to-end tests. So they're being executed. But the great thing is this is not just a list of all the commands that are executed. This can actually be used for debugging, right? So if I stop those, we can see that if I go to one of those tests, right? This is one test. We have all these commands that are executed inside the test. And as you can see, while I'm hovering over those, the application actually changes. So each one of these commands takes a DOM snapshot, which can be used for debugging. I can click on those. I get several information. I can even open up the DevTools to get even more information that is yielded by that command. Right? We can see that the command was type. This is what was typed in. It was applied to this element, and for HTTP requests, this would even yield the response. So I can actually dive into this. I can use just the Chrome DevTools, the tools that we already have and that we love, right? So this is what Cypress looks like. It's really, really amazing. Let's go back to our presentation. And for that, not gonna mirror. So now that's pretty promising, right? But let's take a look at, so when we talk about testing, Cypress is often compared to Selenium, because Selenium is like, well, commonly used, but I think Cypress works substantially different. Is substantially different. So let's figure out why and what makes it so different. So when it comes to configuration, Selenium actually requires us to do several things. It's not a all-in-one solution. We have to install several things. We need to install language bindings. There's the Selenium server. There's many things we have to configure. So we probably hit some roadblocks along the way. With Cypress, configuration is easy peasy. All we have to do is install Cypress, open it up, and it will already create like a default folder structure for us. It has a pretty good default configuration out of the box that we can also modify if we need to do that. When it comes to browser support, Selenium supports all major browsers. Cypress currently only supports Chrome and Chromium-based browsers like Canary. But Firefox is in the making, and it's pretty close. And their plan is to also support Edge and Internet Explorer at some point. But they're going to be released when it's finished. Okay? So both are open source, which might be important to you. But the real difference lies in its architecture, because Selenium uses remote commands across the network, and Cypress works substantially different. So let's see this out. let's see this. Oh, that's my GIF. All right. So this is Selenium's architecture. This is really just a general overview, and it's not really in depth. We don't fully have to understand this, but what we have to understand is that Selenium is a client-server architecture. Basically, every command, it uses the JSON wire protocol, and it converts every command into JSON and sends that via HTTP to the Selenium server, and then the server forwards that request to the browser's native automation APIs. Now, the thing is, the problem is that, first of all, that adds latency. Like, it's pretty slow because of the networking operating, it adds latency, right? And there are many round trips involved. Also, all of this stuff does not work, is not executed inside the browser. It's running outside of the browser. Yeah, just keep that in mind. Now let's take a look at Cypress. Why is Cypress so different? What is so different that makes it reliable and flake-free? So behind Cypress, there's several building blocks involved. And behind Cypress, there's a Node.js process. And the Node.js process does a couple of things. For instance, when launching the browser, it will start the browser with a proxy being set. So there's a proxy provided by Cypress, and the browser is running with that proxy. So it's going to start the browser with that proxy. And then it's going to open up an HTML page that contains two iframes. One for our tests, which are executed on localhost, and another one for our application. You've seen those tests being executed on the left and our application on the right. Those are basically two iframes. So, but the problem is, how do we access all the stuff that our application can access? Like, we want to maybe work with the local storage. We want to access service worker, all these kind of objects. Those are two iframes, and normally we cannot communicate between iframes, right? Because our application could potentially run on a different domain than localhost. Now the trick here, what Cypress does is, because it launches that page and it has access to that page, it will inject a script tag which sets the domain to localhost. And now, because both are running on the same domain, we can actually communicate between those two iframes. And this is what allows Cypress, and this is what makes it so easy to access all these objects like the DOM, the window object, local storage, to access those from within our tests, because both are running on the same domain. That's pretty awesome. And another thing, there's a WebSocket connection between the Cypress instance inside the browser and the Node.js process for anything that requires higher order privileges. So for instance, Cypress has access to the operating system. It can take screenshots. It can record videos and all these kind of things. And because there's a proxy, what does the proxy do? The proxy is actually used for all the HTTP requests. So for every HTTP request that goes out of the browser, it goes through the proxy, out to the web, and then back to the browser. So Cypress operates on a network layer, and it can control and alter every HTTP request. So this is how Cypress works. And what you have to understand is that everything runs inside the browser, right? Everything runs inside the browser. Our tests are being executed inside the browser in the same run loop as our application. That's pretty awesome. So I think once you understand the architectural differences, the major architectural differences, we really realize that we can do things that nobody else can do, right? So let's continue. Debugging. Debugging is pretty difficult with Selenium, I would say, because, well, we don't have that beautiful UI. We don't have these debugging capabilities, and it's pretty difficult to figure out why our tests are failing. With Cypress, it is really, really easy. As you've seen, we have the tests executed on the left. We can click on it. It supports time traveling. All these DOM snapshots along the way that Cypress takes, they can be used for debugging. That's really awesome. When it comes to speed, Selenium is in general pretty slow because, well, the nature of Selenium and the WebDriver, which needs to be spin up, it takes a while. Cypress is like a Formula 1 car. It's super fast because it runs inside the browser. It can go as fast as your browser can go. Right? Waiting for elements. In Selenium, we have a lot of manual waiting, like we need to work on synchronization, we need proper waiting points and all these kind of things. That's like boilerplate we have to write in order to make our tests more reliable and flake-free. With Cypress, we don't have to do that because Cypress, whenever we interact with the DOM, it basically waits for elements to be actionable. Actionable means that the element needs to be visible on the page, it's not disabled, and it's not animating. All right, so that's pretty cool. But if you still need to manually wait for something like HTTP requests, if that's the case, there's an wait command also built into Cypress. When it comes to parallelization, well, both kind of support that, so we can execute tests in parallel to speed them up. Now the question is, why is that yellow? It's yellow because it's only available on certain paid plans, so you actually have to pay for that in order to get that. But let me tell you, it's soon free for open source projects. So if you have an open source project, you can also use that feature. I think that's pretty awesome. At least that's what I did when I heard about this. All right, so let's continue with this. We actually want to get to the live coding, right? So, well, both support headless browsers, but Selenium, while Selenium supports multiple browsers and tabs, Cypress does not. It can only control a single browser. That's because of the nature, like how Cypress works and the architecture, and it will also only support one single tab. So it cannot control multiple tabs. All right, so that's basically an overview and the difference between Selenium and Cypress. Are you ready to code a little bit and see that in action? Okay. Turn that off again. Where is it again? Where? How much? Oh, I still have 9 minutes. That's awesome. So, yeah? This is not important. This is important. So, let's close this real quick, and we're going to restart Cypress. We're going to open it. And now we're going to test our to-do application. So I checked out a different step, which basically created like a simple... It did not. Sorry. So, oh, I just need to get rid of it because it was created on the file system. So I'm just going to get rid of all that stuff. So now we have, I've already created 2 spec files, one for the login page and one for the to-dos application. If I click on login, we're going to see that, I'm going to make that a little bit bigger. Well, it doesn't do anything because there's no tests, right? That's what we have to write. The first step that I'm going to do is there is this Cypress configuration. Remember that I said that it comes with a pretty good default configuration out of the box, but if you click on the third tab, sorry, I cannot zoom in, we can click on configuration and we get a little bit of help of all the options that I have that I can override. So the first thing that I'm going to do is I will set the base URL so that I don't have to repeat myself in my tests over and over again. So I'm just going to set that to HTTP and then localhost and 4,200. So now we're set up. So that's going to be the base URL for our tests. So let's jump into the tests. Before every test, I want to visit my login page because that's the page that I'm going to test. So that's easy. So there's a CI, a SCI, that's the only global object that we have when using Cypress. The only global object that we have to know. So SCI, I'm going to visit my login page. I'm just going to go to /. So let's head over to our test. This is not our test because I have not executed them, right? Let's do it again. We visit our page. That was easy. I mean, that's also easy in Protractor and Selenium. So because I'm working with local storage later on, I'm going to clear the local storage before every test. That's also easy because there's a command, clear local storage. That's easy. We don't have to check it out. But the great thing is, see, those tests are constantly being re-executed while I'm working on my tests. Cypress actually allows you to develop test-driven, which is really, really painful to do that with Protractor, seriously. So let's write our first simple test. We're going to check if our page contains this text, right? That's easy. I can do sci.contains. That's going to look for that particular string that I'm passing in on my page. It's basically an implicit assertion, so it's built into that command. So I can say, hello back, like that. We're going to see that. It's being re-executed. Ooh, it takes a while. So it's not failing right away, but somehow I was clumsy and I did a mistake. So my test is failing. It timed out, retrying, expected to find content hello back, but never did. Well, I have a typo. So I'm going to fix that real quick. Re-execute my tests, and oh, welcome back. Sorry for that. Welcome back. Re-execute the tests. What did I do? Oh no! Sorry. Welcome back. Ooh, saw how fast I was? Wow. I did like one change and boom, test executed. That was nice. Now let's do the fun stuff. We want to test, so it should set auth token in local storage on successful login. So we have to work with the local storage, and we also have to work with HTTP requests. Okay, so the first thing in order to work with HTTP requests is we have to set up a server. We're basically telling Cypress in order to control, so we probably want to stop some, spy on some objects, and we have to set up a server. So we're going to say sci.server to get this up and running. That's setting up. And next, we're going to spy on one specific request. So I'm going to say sci.route. I want to listen for all the login requests. So this is going to be a post request, and the URL is going to be auth, and then /login. That's it. I'm also assigning an alias so that I can reuse it easily in my test. So I'm going to say as. That's assigning an alias. So this is my login request. I can name it login request, like that. That's not going to change anything. But we click on this our test. We could now see. Ooh. We don't see that. Why? Second test. I'm sorry, that's the second test. We can see that Cypress now knows about this route that we're spying on. So here's this hash symbol, which indicates how often that request went out of the browser. So we can check that out later. OK, so we've got our route. Now, the cool thing about Cypress, we can implement custom commands. So I'm going to look for like all these elements that I need. For instance, here it's the input field username, the input field password, and also the login button. I don't want to use classes because classes should be used for styling purposes only. And what I typically do in my tests is if I go to my login page here, I introduce these data sci attributes, and I'm just setting them to, this is the username field, then I have one for the password, and I also have one for the login button. So those attributes are being used inside the test, right? Because, yeah. So in order to implement a custom command, we can go under support. So that's the folder structure that is generated by Cypress out of the box without doing anything. We can go into command, and I'm not going to type it out. I already have a snippet for that, get by test ID. So this is what a command looks like, really simple, just adding a command with that name to the global sci object, and then we can just leverage built-in commands to build our own custom commands. That's pretty nice. So we got our custom command in place, and now we're going to find the username. So I can say sci.get by test ID. I'm going to say I'm looking for the username. And then I want to type in the username, of course, which is Peterpan. And then I also want to blur that field. Nice. I'm also going to do that for the password. And now the password is no longer a secret, but so I did those steps, so I can remove that. Next, I need to click on the login button. So I'm going to say get by test ID, and I need to look for the login button. I'm just going to simply click it. That's it. That's easy, right? Writing and going back. Oh, my test was already executed. I didn't expect that. That was fast. Whoa! So, all right, I'm clicking on a login button, and we're successfully redirected to the to-dos page. That's nice. And what I want to show you is I can see those are the DOM snapshots on the left-hand side. When I click on one of those on the actual HTTP request, see that yellow little badge? That's like the alias. It also visualizes those aliases. That makes it really, really easy to write tests. So I can click on that. I can open up Chrome DevTools here, and I see all these nice information. I can see so the request object, the response object, and much more. We can really go into this. So what I want to do is I want to test if the status code is 200. That's easy. So I can say I'm getting, because I've assigned this alias here, login request, I can now get it. I can ask for that. So Cypress will wait for that before doing any assertions. So I'm getting my login request, and I have to add this @ symbol. That's how we ask for aliases, right? So please give me the login request, and then there's this its command, which I can go deeply into properties and like really deeply get out properties. So I can just dot into those. So what I want to do is I want to check the status code, and I say should, and then equal 200. So again, it uses a BDD syntax from Mocha. So let's see that. Ooh, that was fast. See? Now I got my first assertion, and it's passing. That's nice. So next, now we have to work with local storage. That's going to be difficult, no? No. It's going to be easy peasy. So what we can do is I am going to do the same. So please give me the login request. 8 seconds. Do I have 1 more minute? Oh, thank you so much, because this is really cool. Login request. So then I can say it's, right? So I need to dig into the response. So again, I'm going to click on it because I don't know how the response looks like. I'm going to click on response. It has cool, has a body, and then access token. Cool. So I can say response body and then access token. And now I want to write my assertion. So here I get the access token. I'm going to write a function. And I can say expect my access token to equal, and then watch this. See that? Boom. See how easy it was to work with local storage? You can do the same. You can even expose, if you use Redux or something like that, you can expose your store as a global object and just use it. You can access anything that your application can access. This is really, really different from Selenium-based testing tools. So I'm not going to do the rest because I'm running out of time. I'm 1 minute over. So going back to my application, to my slides, well, that's pretty much it. There's some inspiration, so if you want to look at some tests, you can check out these links. Thank you so much for listening to me and watching me live code this. Thank you so much for this. Here's the reference that I used for my talk. Yeah, thank you so much. Have a good evening. Take care.